blockchain access control. In this design, we'll showcase how we can use blockchain technology to secure our data. So first, we start by designing smart contracts. These smart contracts will store, modify, and execute instructions that may be needed for our implementation. So we start off with the first smart contract, and we can call this smart contract access. Now, what this contract does, it gives access permission to other smart contracts. But we also went a step further and designed an identification smart contract. Now, this identification smart contract can be used to store identity information of anyone in the organization or in a region. So we'll name this identity. So now we have access giving permission to identity for anyone or any user or any employee that wants to modify the data, and we have identity providing access with verification of identity. Now that seems simple, but now we need this to be in a blockchain network in order to benefit from blockchain features. So we start by adding nodes to a blockchain network. We can start by having a full node. So now this node would be called a boot node. What boot node means is that this is the first node that initializes the network. So this boot node will carry the first state and will write the genesis block to the network. And therefore, we have our data in this node. Remember that this data also carries the contract data. So now, this contract also resides here in contract ledgers. And this is the data in one node. So now, already, this node is protecting the data, and the blockchain implementation is used only on one node called the boot node. But we may want to have multiple nodes in order to make the network more secure, to provide access to other locations or even other companies that may need to benefit from this network. So we can replicate, or we can add another node which is an exact replica of this node. But now this won't be a boot node anymore, it will just be a full node. Now this full node and the boot node are connected via the internet. This can be locally, or it can be over an IP service provider, which means this node can be in location A and this node can be in location B, and both nodes will be there. So you can decide to have multiple nodes across the world or across the country. So now with all these nodes contain the same blockchain data and they are all in sync. But what's also interesting is that we can use these nodes to provide access to other companies or anywhere in the internet. So one company can be here accessing the node here. Now this node will be able to submit blockchain data and blockchain information. So we can call it company A. Company A is in control of the boot node. We can also have another company, we can call it company B. So this will be company B. So you can have company B accessing this node, or it can also access this node or this node. It can access any node for that matter. But what's also interesting is we can have another company that does not have a node, but we gave it permission to use the network via the internet. So we can have company C located here, and company C is connected to the network via internet. So this company resides with this node, this company resides with this node, and the other nodes are just used to protect the data, or C can also take on one other node. So now, how do we ensure that all nodes secure the data? So remember, we started with the boot node, and the boot node is the first one to secure the data. We are using an algorithm called proof of authority. So now we need to authorize all of these nodes, right? So we can just think of this as being like this at the moment, right? So the boot node will first need to authorize that another node can verify transactions, and we have this node right here. So now the network is protected by two nodes, which means any transaction submitted to the network needs to have two verification. And we can have another node right here. Now again, the network is now protected by three nodes, but we only need two verification, or two nodes need to verify transaction for the network to work. Now what this means is the algorithm says majority wins, or what that means is if we reach the same agreement by 50 plus 1 percent of the nodes, which means at least one more than 50% of the nodes agree to the same state, then the state is true, or the transaction has succeeded. So if any of the nodes tried to act unlawfully to the network, then the transaction will not be verified. Again, we can add the other node. And now, this node again will protect the network. So now to compromise the network, you need to hack at least three nodes in order to have the network fully compromised. If you hack any of the nodes, even if it's the boot nodes, these three remaining nodes will still protect the network. Now again, what if company B decides to pull out on the network, or decides not to act on the network, but they still have their node running? Again, since we have the 50% plus 1 rule, we can decide that all of these three nodes vote out against company B and its node. So what that means is company B and this node will be now disconnected from the network. While the node can still sync from the network, the node cannot verify any transaction, which means whatever company B was doing in the network can no longer be done. So therefore, company B doesn't exist anymore. And we're still left with this. Now you may be wondering, in current databases, we need a way to back up our data in case anything happens. So for that, we can add another node right here. But now, this node will not be a data accessing node, but it will be an archive node. Now, this archive node will only store data from the network or from any node. The archive node, even if the network is compromised, will still be able to create a boot node from its state that will be the exact replica of the node at that moment it was compromised. So that means it's rolling back or reverting to the previous good state. So our archive node will need to be able to sync data from one node or two nodes or the network or a combination of three. It will figure out which one is the lowest latency, and therefore it will be able to sync the data. I hope this information was useful, and thank you.